Good day, everyone, and welcome back to our YouTube sessions. Today, we have a topic on the board. I'm sure you can see that we are going to talk about organic molecules, organic reactions. So, we have a few organic molecules that are here on the board, as you can see. So, if it's your first time today to join us in our YouTube sessions, make sure that you also have time to press subscription button. You also have time to press notification button so that as we are going to post more content on our channel, you also be able to notified of the content. So at the same time, let's get back to our content. Today, like I said, we want to talk about organic molecules. So there's 5 organic molecules that we have on the board. So we want to be able to understand how do you answer questions regarding these organic molecules. So the first thing that I want to say to you is that at this point, you must be able to know the organic molecules that you have on a homologous series, that ranges from hydrocarbons, alcohols, haloalkanes, etc., etc. So let's get into the questions that you have on the board. So the first question that you have here is the first question where you ask it, which one between A, B, C, D, E, which one has this general formula, which is CnH2n. How do you answer such a question? So at this point in time, you must be well versed with your general formulas. So the general formula that we have here on the board, it is a general formula of alkanes. So, which means we come back to organic molecules, we need to find which one is an alkane. So we can see that all these ones from bottom going up, they are not alkanes. Our alkane is the first one, which is A. So our answer in this case is A. And A, it is methane. All right, as we move on to the next question, 2.1.2, we want to understand, the question is, which one is a haloalkane? So the question is, which one amongst these is a haloalkane? How do you identify an alkane? You identify an alkane by understanding that alkane are simply alkanes that have a halogen as part of their structural formula. So we can see in this case that the second one doesn't have a halogen. We have the third one, the fourth one, the fifth one, it has a fluorine. There's a fluorine here atom, so that means our answer, it is E. Why? Because this one has fluorine, and fluorine, it is a haloalkane. So as we move on, our next question, which is question 3, we are asked which one, 2.1.3, the question is, which one is a functional isomer? Functional isomer. So functional isomer of what? Functional isomer of ketone. Which one is a functional isomer of ketone? You can identify functional isomers of ketones by understanding that we have only 2 groups of functional isomers in the homologous series. The first one is esters and carboxylic acids. They are always functional isomers of each other. The second group, it is ketones and aldehydes. They are functional isomers of each other. So at this point in time, if we want functional isomer of ketone, then that molecule must be an aldehyde. So amongst these 5, which one is an aldehyde? It is D, propanol. So D, propanol, is our answer. It's a functional isomer of ketone. So as we move on to the next question, which is question 2.2. So on 2.2, what do we have? The question that follows is that we are supposed to deal with compound C. So dealing with compound C, this is our structure. As you can see, our structure for compound C, it is like this. And our compound C, it has an OH. So because there's an OH, hydroxide functional group, it means C is an alcohol. It means C is an alcohol. So since C is an alcohol, we need to understand now, how do we answer questions on alcohols? So before you can answer the question, understand types of alcohols, understand naming of alcohols, understand the nomenclature. So let's get to the question. What is the first question? The first question, 2.2.1, it talks about type of alcohol. What type of alcohol do we have here. So if you look closely, we can only determine types of alcohols by understanding the concept of the carbon carrying the functional group. So our functional group is the hydroxide functional group. So this hydroxide functional group, it is carried by this alcohol, by this carbon, sorry. So it is carried by this carbon. Now this carbon is surrounded by 1, 2, 3 other carbons directly. So that makes this this molecule to be a tertiary alcohol. To be a tertiary alcohol. It's a tertiary alcohol. Why? Because the carbon that is carrying the functional group is surrounded directly by 1, 2, 3 other carbon atoms. So it's a tertiary alcohol. Now, the reason why it's a tertiary alcohol is because the carbon which is carrying the functional group, I'll use the shortcut, the functional group is attached to 3 other carbon atoms. So the carbon carrying the functional group is attached to 3 other carbon atoms. That is our reason why it's a tertiary alcohol. The next question is the IUPAC name. Of this. So, how do we give names to alcohols? How do we give names to alcohols? Let us understand how do we give names to alcohols. So the nomenclature says that step number one is to identify longest chain. So let us look at this molecule that we have here. The longest chain starts from here 1, 2, 3, 4, 5, 6, 7. So this is the longest chain here. The way I've highlighted it, you can see it has 1, 2, 3, 4, 5, 6, 7. It has 7 carbons. That is the longest chain. Get it right. Longest chain. Longest chain doesn't need to be horizontal only, or doesn't need to be vertical. But identify the longest chain. After identifying the longest chain, how many carbons are in the longest chain? We have 7 carbons. There is 7 carbons in the longest chain. So let's give it the root name. So let's give it the root name. The root name is going to be heptanol. But don't forget, the heptanol must have a number of the position of the functional group. So the next step is to understand position of Fg, the functional group. Position of the functional group. So let us find the position of the functional group. This is our OH. As we can see, if you count from left, 1, 2, 3, 4, 5, it means the functional group is on carbon number 5. If we count from the other side, from right, 1, 2, 3, the functional group is on carbon number 3. And don't forget that our molecules, our chemicals, they must get the smallest number possible. So therefore, we must count from where it is nearest. That is nearest from the right. So 1, 2, 3, it's on carbon number 3. So therefore, it's no longer just heptanol. It is going to be heptan 3 with an OL. So this is heptanol 3. Position of the functional group has been given. The last step now is to understand what we call position of alkyl, position of the alkyl group. Position of the alkyl group. What is the position of alkyl group? It is the position of the branch. Now look at our branch. This one was not part of the longest chain. So that becomes the branch. So if that becomes the branch, that means what is the position of this branch? It's still on the same carbon, which is carbon number 3. So this is going to be position number 3 for the branch. But how many carbons are in this branch? There is only 1 carbon. So it's going to be a methyl. Now let us join these two to form one full name of this IUPAC name. Is going to be 3-methyl It is 3-methyl heptane, 3-methyl heptano 3. So this is the full name of carbon number C. So let's move on. The next question is, what is going to be the functional group? What is the functional group of this? The name of the functional group. The name of the functional group, it is a hydroxyl functional group. We say it's a hydroxyl functional group. It's a hydroxyl functional group, which is question 2.2.3. It's a hydroxyl functional group. So question 2.3 is done. We move on to the next question, which is question 2.2 we are finished. We move on to 2.3. So what do we have on 2.3? On 2.3, we are dealing with organic molecule number B. So we are dealing with number B. We want to understand how do we answer question about organic molecule number B. So the first question that we have on number B is structural formulae. Structural formulae. So we're supposed to draw the structural formula of propyl ethanoate. Propyl ethanoate, as the name suggests, let us write it here, propyl ethanoate. So propyl ethanoate, the structural formula, we understand that this is an ester. So an ester, what we understand is that it is made from one part from the alcohol, another part from the carboxylic acid. So now, because this is propyl, prop means it was made from 3 carbons of alcohol. So therefore, we're going to have 1, 2, 3. But the root name, which is ethanoate, it means there's 2 carbons from the carboxylic acid. So therefore, we're going to have an oxygen, we're going to have a carbon with this and 1 ethanoate, 2 carbons. Then this is the structural formula for propyl ethanoate. So this is the structural formula for propyl ethanoate. As you can see, 3 carbons on this other side divided by oxygen atom, and then 2 carbons on the other side where it came from the carboxylic acid. So this is the structural formula of number B, which is propyl ethanoate. So as we move on to the next step, the next question is structural formula of the functional group of this. Now, this is an ester. The question, if you ask a structural formula of the functional group, the functional group is there right in between the 2 sides where there's carbons. So the functional group is going to have 1 carbon connected to the oxygen. Then we have an OH. So structural formula of the functional group of its isomer. So this is for the isomer. So let us understand that the functional group of the isomer. What is the isomer of an ester? It's a carboxylic acid. So since it's a carboxylic acid, what is its functional group of the carboxylic acid? This is the functional group of the carboxylic acid, as you can see. So this was question number 2.3. So let us move on to the next question, which is 2.4. So on question 2.4, which organic molecule are we dealing with? We are dealing with organic molecule number E. So number E, we have 3,3 difluoro 2-methylpentane. So the question is, write down structural formula. Structural formula. So structural formula of compound E, I want us to understand that since we have a 3,3 difluoro and 2-methyl pentane. Let us start from the end. This is a haloalkane. From the end, we have 5 carbons on the longest chain. So we start by putting 5 carbons on the longest chain. Why 5 carbons? There is pentane at the end. So pentane at the end, it entails we need to put 5 carbons in the longest chain. So our longest chain is going to have 1, 2, 3, 4, 5. Then after that, we need to understand the functional group. The functional group is 3,3 difluoro. There are 2 fluorine atoms that are on the same carbon, which is carbon number 3, 3,3. So therefore, we must understand the position of the functional group first. The position of the functional group, 3,3 difluoro. So we have carbon number 1, 2, 3. So we also have a methyl, a branch, which is on carbon number 2. So carbon number 2, we have a branch. This is the branch on carbon number 2. Then on carbon number 3, we have a 3,3 difluoro. So we have on carbon number 3 fluorine atoms, and we have this structural formula. This is going to be the structural formula of 3,3 difluoro, 3,3 difluoro, 2-methyl pentane. 1, 2, 3, 4, 5. 5 carbons for pentane. 3,3, position number 3, there's 2 fluorine atoms, difluoro. So this is going to be the structural formula of number E. The structural formula of number E. So let us move on to the next question. So the next question that we have carbon A. We're dealing with A now. But dealing with A, what are we given? On A, we are given a combustion reaction of this, which is CH4 plus in excess 2O2 with carbon dioxide. We also have 2H2O, which is going to be in gaseous state. So this is what we are given on compound A. Compound A undergoes combustion reaction. So if it undergoes combustion reaction, that means one thing. It means alkane is an alkane, is going to react with oxygen in excess, and then the products that we have carbon dioxide and excess of water being produced as products. So now what is the question? On the question we are given that during the combustion of this alkane, which is methane, 2,75 kgs 2,75 kgs of CO2 was formed during the reaction. So the question is, we want to know the mass, small letter a, mass of CH4, that is needed for this to produce 2,75 kgs. So let us understand. Our information is like this. We have an equation, then at the same time, we are told that 2,75 kgs of CO2. CO2 in this case is a product which has been formed. So CO2 has been formed 2,75 kgs. But the question is, it was formed by how much kgs of our alkane, which is methane? So we want to determine that. Step number 1 is to use the given information. The given information is that we are given small letter m, which is 2,75 kgs. So we must convert from kgs to kilograms. How do you convert? We multiply by 1,000. It's going to be 2,750 grams. So we are going to apply formulas for stoichiometry. So the first formula is that N is equal to small letter m divided by capital letter M. What are we dealing with? We are dealing with CO2 first, carbon dioxide. So small letter m, we have 2,750 divided by capital letter M. It is the molar mass of carbon dioxide. For carbon, we know is 12 plus. For oxygen, it's 16 times 2 atoms. So we want to understand what is going to be the answer to this if we divide the two. Dividing the two is going to give us 62.5 moles. So there's going to be 62.5 moles of carbon dioxide that has been formed. So the next step is to understand the concept of molar ratio. Concept of molar ratio, we come to CH4. It is 1 here. CH4, the molar ratio for CH4, in this case, it's 1. There is 1. Where are we getting 1? The coefficient of CH4 is 1. We come to carbon dioxide, the coefficient is also 1, which means the molar ratio between CH4 and carbon dioxide, it is 1:1. So therefore, if it is 1:1, it means number of moles of CH4 as well, they are also going to be 62.5. Why 62.5? Because the molar ratio here, it is 1:1. So therefore, number of moles for CH4, it is 62.5. Now, if we have number of moles of CH4, that means it's now possible to find small letter m using the formula. So to find small letter m using the formula, n is equal to small letter m over capital letter M. For CH4, we're doing this for CH4. So number of moles is still 62.5. It is equal to, it's time to substitute. Molar mass of substance, small letter m, we don't have. But molar mass for CH4, let us determine molar mass for CH4. Carbon dioxide, we have carbon. First, for carbon, it is 12 plus hydrogen, it's 1 times 4 atoms. So we are going to have this. Let us cross multiply 62.5 times 12 plus 1 times 4, which is going to give us 62.5 times 16. Our answer is going to be 1,000 grams. 1,000 grams. This is the final answer that we have. It means 1,000 grams of CH4 or of methane reacted to produce 2.75 kilograms of CH2. So this was the organic molecules part of our question, which means now we need to move on to the next question. So as we move on to the next question, let us separate our videos so that at least they can be shorter clips and you'll be able to focus on the same clip one by one. So we're moving on to the next video, which is going to be the video on the next question, that is intermolecular forces and also organic reactions. So keep watching. Thank you so much for watching our videos. See you next time.